Welcome students to this new video on differentiation for the 12th class students of Maths and Stats. Earlier we have seen the rule for differentiation of inverse functions, and then we solved some examples on differentiation of inverse functions. This is another question set for the same purpose. We shall deal with some inverse trigonometric functions, and then we shall try to find their derivatives and simplify them if possible. See the examples list here. These examples are taken from exercise 1.2 and this is question number 6. Earlier we have solved the previous questions. The cot inverse log of x, sec inverse e raised to x, these are different, e raised to minus x in fact, cos inverse 1 minus x square, cos cube, cos inverse of x cube, etc. Now let us solve these questions one by one. See this first question. Y is equal to, we should take tan inverse of log of x. This is what you do normally when you differentiate a function. We take it as y, and then this is a straightforward differentiation. Just compare this tan inverse log of x with some standard function. What is the standard function comparable with this? It is tan inverse of x, whose derivative you must know. It is 1 upon 1 plus x square. So the derivative in this case, if you differentiate this with respect to x, what you find is the derivative is dy by dx is equal to, like the right hand side also, d by dx of tan inverse of log of x. So we have to find out this derivative by using this comparison. Derivative of tan inverse of, this is the derivative of tan inverse x is 1 upon 1 plus x square. So derivative of tan inverse log of x is 1 upon 1 plus, in place of x we have log of x, so it is just log of x square, and then into, as usual, d by dx of the replacement of x. The replacement of x, when we compare tan inverse x and tan inverse log x, it is log of x. So we can write this as 1 upon 1 plus log of x whole square into then d by dx of log of x is 1 upon x. And you can finish this in a better manner as 1 upon, take this x front, x into 1 plus then this log x whole square, and then bracket complete as it is. This is dy by dx for us. Now this is a new example. We have to differentiate sec inverse of e raised to minus x. We have solved this example, earlier example, in tan inverse of something. Now it is in sec inverse of something. So we need to know the derivative of sec inverse of x. So what is the derivative of sec inverse of x? Sec inverse x, its derivative you must know. It is 1 upon x root of x square minus 1. So in the textbook it is originally examples cosec inverse of e raised to minus x. I have changed it a bit, but you can do it in the same manner. So let us take first of all, as usual, the function as y. So let's y is equal to sec inverse of whatever function we have, e raised to minus x. Then we differentiate with respect to x, as mentioned here. Differentiate with respect to x, we get dy by dx is equal to, left side derivative dy by dx, right side derivative d by dx of right side. sec inverse of e raised to minus x. Now I have to understand that derivative of sec inverse of the sec inverse of x is this. So derivative of sec inverse of e raised to minus x is 1 upon x root of x square minus 1. So it is now not x but e raised to minus x into root of e raised to minus x square minus 1. So the derivative is 1 upon e raised to minus x into root of e raised to minus x square into minus 1. But then multiply that by dx of replacement of x. When you compare this sec inverse of e raised to minus x with sec inverse of x, what was x replaced by? X was replaced by e raised to minus x. So into d by dx of e raised to minus x, which can be written further as 1 upon e raised to minus x as it is, then into root of e raised to minus x square minus 1 into this derivative is e raised to minus x, the derivative is e raised to minus x as it is into d by dx of minus x, because when you want to find derivative of e raised to minus x, it has to be compared with its standard function e raised to x, whose derivative you know is e raised to x only. So e raised to minus x, if you differentiate, you'll get e raised to minus x into d by dx of replacement of x is d by dx of replacement of x is minus x. So d by dx of minus x is extra written there, which is 1 upon e raised to minus x, 1 upon e raised to minus x into root of e raised to minus x whole square minus 1 into this derivative, if you work out, e raised to minus x is there into minus x, its derivative is minus 1. If you see, this e raised to minus x cancels with this e raised to minus x and minus 1 remains, this minus 1 remains. So if you solve it further, you get what you get here is now what is remaining is minus 1 dy by dx is equal to minus 1 whole divided by this minus 1 whole divided by root of e raised to minus x whole square. I may write that as 1 upon e raised to x whole square, because e raised to minus x means 1 upon e raised to x, and minus 1, which is further written as minus 1 whole divided by, how do you write it further, root of 1 upon e raised to x whole square means 1 upon e raised to x square minus 1, because 1 square is 1 only, e raised to x square is written there, which is minus 1 upon whole root of 1 upon e raised to x square is 1 upon 1 minus, it's 1 minus e raised to x square divided by e raised to x square, which can be still simplified as I shall write it here, dy by dx is equal to, now this minus 1 remains as it is, whole divided by this whole root of, now 1 minus e raised to x whole square means e raised to x raised to 2, that is e raised to 2x. And this whole divided by e raised to x square is in the root, and it's in the root. So root of e raised to x whole square is just e raised to x. So whole divided by is root separated e raised to x. This is what you have in the answer. So it can be still written as minus 1, and this will be written as minus 1 into e raised to x divided by this denominator goes to numerator, and divided by whole root of 1 minus e raised to 2x. That is the answer. dy by dx is equal to minus e raised to x divided by 1 minus e raised to 2x. Now this is a new example. Cos inverse of 1 minus x square we have to differentiate. So what we do is, as usual, we have taken y is equal to cos inverse of 1 minus x square. Now the differentiation process starts. So differentiating with respect to x, I get y differentiated as dy by dx is equal to d by dx of the right hand side is cos inverse of 1 minus x square. Now for differentiation of cos inverse of 1 minus x square, I must remember derivative of cos inverse x. So derivative of cos inverse x is minus 1 divided by the root of 1 minus x square. So derivative of cos inverse x is cos inverse x's derivative is minus 1 upon root of 1 minus x square. So in the same manner, the derivative in this case is going to be minus 1 upon root of 1 minus, what is our x in this case? Cos inverse of 1 minus x square and cos inverse of x. So x is replaced by 1 minus x square. So just write that 1 minus x square there. And its square. And then into d by dx of the replacement of x, 1 minus x square replacing x. So derivative of 1 minus x square. This gives you minus 1 upon whole root of 1 minus. Now expand this because it is sorted out, so you can simplify this. In the bracket, a minus b whole square formula is a square means 1 minus 2ab means 2x square plus b square means x square square is x raised to 4. We use that a minus b whole square formula. Into d by dx of 1 minus x square is derivative of 1 is 0 and derivative of x square is 2x. 0 minus 2x is just minus 2x. So we can write this as dy by dx is equal to this 2x as it is divided by, in the denominators you have whole root of 1 minus 1 cancels, so it will be just 2x square minus x raised to 4. What you can do more here is keep this 2x as it is, and in the denominators you have this root of x square is common factor. 2 minus x square remains inside the bracket, which is equal to 2x divided by this x square's root is x into root of 2 minus x square. This x cancels this x and you get answer equal to 2 upon whole root of 2 minus x square. This is dy by dx in the end. That's how. This is that last example which we had written in the list. Cos cube of cos inverse of x cube. What we do is cos cube of cos inverse of x cube is taken as y. Then the simplification step. When you see cos cube of x, it means it is equal to cos x whole cube. In the same manner, cos cube of this bracket is equal to cos of that bracket raised to 3, just like this. Now you can simplify this as cos of cos inverse of x cube. Now there is another formula, cos of cos inverse of x. What is this equal to? I told you to remember these properties. Cos of cos inverse of x is just x. Even cos inverse of cos x is x. Now this property, if you apply, it will become cos of cos inverse of x cube is just x cube, and that whole bracket, this is just x cube, this is x cube, and then cube of that x cube, which turns into just x raised to a raised to m raised to n raised to mn. That means x raised to 3 into 3, 9. This is your y in the simple, very simple form. Now you can differentiate it without using too many different difficult things. Differentiating with respect to x, you get dy by dx is equal to d by dx of just x raised to 9. And what is d by dx of x raised to 9? It is 9x raised to 8. dy by dx is found. So though it looked complicated in the beginning, you used one trigonometric property there, and this is how you will solve the examples in the upcoming questions in this exercise 1.2. So let us see those examples. Now have a look at this new set of examples. We have to differentiate cos inverse of root of 1 plus cos x whole divided by 2, sine inverse of cos x, cos of 5 raised to x, cot inverse of cos x upon 1 plus sine x, tan inverse of 1 minus tan x by 2 upon 1 plus tan x by 2. This sort of examples, these are special category. We have to think about some properties, trigonometric properties. If you look at 1 plus cos x, I told you earlier to remember some trigonometric formulae. This set of examples needs those properties, trigonometric identities, trigonometric formulae, inverse trigonometric formulae. These all are required here. 1 plus cos x, this is a half angle formula, you must remember. It is 1 plus cos x is 2 cos square x by 2. That will simplify this. Now this needs sine inverse of cos, this needs some different formula, allied angle formula. This cos of 5 raised to x can be converted into sine of something. Then this cot inverse of cos x upon 1 plus sine x. Here you need half angle formula. Here also you need one allied angle formula. So let us see these examples one by one. So starting with the first example, cos inverse of root of 1 plus cos x whole divided by 2. Like I said, I will use the property 1 plus cos x is equal to 2 cos square x by 2. Now this is then written as cos inverse of root of 1 plus cos x, like we said, is 2 cos square x by 2, and whole divided by, then it is 2. This is whole thing inside this root. That becomes cos inverse of this 2 cancelled, this 2 and this 2 gets cancelled, and you get root of just cos square x by 2, which is cos inverse of root of cos square x by 2 means simply cos x by 2, and that is equal to just x by 2, because cos inverse of cos x is x only. So this x by 2, cos inverse of cos of x by 2 is just x by 2. This is your y in the simplest form. Now if you differentiate with respect to x, what will you get? You will get dy by dx is equal to x by 2's derivative, it's 1 by 2. 1 by 2 comes out and derivative of x is 1. Now differentiating this, you need some other property to remember here. Here we have cos inverse of sine of something. We require cos of something. Yes, cos inverse of cos of 5 raised to x would have been fine, but cos inverse of sine of something is not okay. So what we do is we write this sine. You can see sine theta, is cos of pi by 2 minus theta. You can write it like this also. So sine theta can be any time written as cos of pi by 2 minus theta. So we shall replace this sine of 5 raised to x by, this won't change, cos inverse of. Now here we'll make that change. I can write that as sine replaced by cos of pi by 2 minus 5 raised to x. Now this can be written equal to cos inverse of cos of this bracket is that bracket. Cos inverse of cos x is x. So cos inverse of cos x is just x. What I get is just pi by 2 minus 5 raised to x. This is your y in the simplest form. So now if you differentiate with respect to x, what you get is dy by dx is equal to d by dx of right side. D by dx of pi by 2 minus 5 raised to x, which is d by dx of pi by 2 is 0, minus derivative of 5 raised to x, which is 5 raised to x log 5. So you can finish it as minus 5 raised to x log 5. This is dy by dx. Now to solve this example, I need to use two more formulae. Cot inverse of cos x divided by 1 plus sin x. Cos x as per the half angle formula is cos square x by 2 minus sin square x by 2. And 1 plus sin x is cos x by 2 plus sin x by 2 whole square. If we use those two formulae, what we'll get? It will be cot inverse of cos x by 2 means cos square x by 2. 1 minute. Cos square x by 2 minus sin square x by 2 and whole divided by 1 plus sin x is cos x by 2 plus sin x by 2 brackets with it. These two look very similar, these two expressions, but slight differences there. Cot inverse of, you can write this as now cos square x by 2 minus sin square x by 2 is factorized. As looking at the denominator, I need to factorize them. Cos square x by 2 minus sin square x by 2 is cos x by 2 plus sin x by 2 into, now I will write in the first factor, cos x by 2 plus sin x by 2, the first factor, multiplied by, the factor is cos x by 2 minus sin x by 2, whole divided by cos x by 2 plus sin x by 2 bracket square means same bracket, cos x by 2 plus sin x by 2 written twice. It is cos x by 2 plus sin x by 2 bracket multiplied by the same bracket, cos x by 2 plus sin. This is what we are doing in such examples. You will come to know this. Later on you will solve similar examples. You would be very familiar with this step. Now cancelling the common factors, cos x by 2 plus sin x by 2 getting cancelled, and then the remaining part is cot inverse of what? Cos x by 2 minus sin x by 2 divided by cos x by 2 plus sin x by 2. Now this is also a special kind of expression. You will use it many times. See, we are just simplifying this function. We haven't yet started any differentiation step. So cot inverse of cos x divided by 1 plus sin x is simplified like this using the formulae. Now here we have come up to this. Now cos x by 2 minus sin x root upon cos x by 2 plus sin x by 2. This can be simplified by dividing both numerator and denominator by cos x by 2. We shall divide both numerator and denominator by cos x by 2. So what will you get? Y is equal to cot inverse of, imagine that you are dividing this and this by cos x by 2. So cos x by 2 upon cos x by 2 is 1 minus sin x by 2 upon cos x by 2 is tan x by 2 divided by, what are we doing here? We are dividing numerator and denominator by, we are dividing numerator and denominator by cos x by 2. Remember that, cos x by 2. So division by cos x by 2 by cos x by 2 1 minus sin x by 2 upon cos x by 2 is tan x by 2. Same thing, cos x by 2 upon cos x by 2 1 and 1, and next step will be plus sin x by 2 upon cos x by 2 will be 1 plus tan x by 2. So now this is cot inverse of 1 minus tan x by 2 upon 1 plus tan x by 2. This is further written as cot inverse of, this is, you must remember, it is tan pi by 4 minus x by 2. It is tan pi by 4 minus x by 2. Or we can do it in a slightly better manner. After this, I can make the change. I can write this cot inverse of this bracket as tan inverse of something easily. Cot inverse of a upon b can be written as tan inverse of b upon a. You know that rule. That formula is also there. So cot inverse of a upon b written as tan inverse of b upon a. That means numerator will be 1 plus tan x by 2. And the new denominator will be 1 minus tan x by 2. So this gives tan inverse of, now this is a known formula, 1 plus tan x by 2 upon 1 minus tan x by 2 is tan allied angle formula, pi by 4 plus x by 2. Remember this allied angle formula, tan pi by 4 plus x by 2 is 1 plus tan x by 2 upon 1 minus tan x by 2, and tan pi by 4 minus x by 2 is 1 minus tan x by 2 upon 1. This is tan pi by 4 minus x by 2. I didn't use that, but that is also there. So this gives simply pi by 4 plus x by 2, because what we have got is tan inverse of tan of anything. Tan inverse of tan of x is only.
After writing this as y equal to pi by 4 plus x by 2, its derivative can be found easily. Its derivative is pi by 4's derivative is 0 plus x by 2's derivative is 1 by 2. So 0 plus 1 by 2 will be simply 1 by 2. That's how we can solve these examples. We shall see more examples from the exercise, same exercise, in the next lecture. Thank you.